Since I have told you that something important, OSI was derived to simplify to become TCP/IP. In TCP/IP, we talked about the last top three um, layers were summarized or will merged in one layer called the application, and I told you that this is no longer our concern. We don't concern about these. We are not developers of applications or format or sessions, whatever. We don't care about that. We are network engineers. So honestly, we care about the first four layers: layer 1, 2, 3, and 4. So I will start right now talking in detail about the examples and the approaches of the layer 1, 2, 3, and 4. Like starting from now, layer 1 technologies, like what it's called the physical layer. And inside the physical layer, everything is physical, like what? Like everything that you can see by your eye. Physical means something that you can touch, you can hold, and you can see. So this is something physical there, not imaginary thing that's happening in the technology and leave it to the magic of technology. No, it's not. I mean, not in that way. It's something physical, so I need to see it. Show me that. It's important to see it in that way. So everything physical is considered there, like the ports, like the cables themselves, and the best example will be the cables themselves that we'll talk about them. So the cables that connect the network, their connectors, the end of the cable, what is at the end, how am I going to insert or inject that cable into something, a port, by using a connector that will connect the cable to the port. So the first type is called the copper or the Ethernet. Still, most of them are Ethernet, but the copper cables that were made of pairs of copper. So they look like that, where you have this blue pair, orange pair, brown pair, and green pair. Each pair is two light, or not light, but too slim or too thin, too thin copper cables or copper wires, actually, both of them. But you can see them that all of them here are twisted. Why? Well, actually, the method that these operates using is actually I need to strengthen my grammar more. But again, if I have this computer connected to that, and let's just assume as simple as possible that I want them to be connected directly by one cable, like a cable inserted on this end and that end, and they should operate. Just the perfect scenario. Consider it in that way. So what I will do will be, I need to connect them via cable, and I will use these double or that pair of copper cables, but they work on the matter of, they function in a matter of electric circuit. So I need a closed circuit of electricity to start sending the bits, the ones and zeros, throughout these cables. So I will connect a cable, but this is one cable, and I will extend another. In that way, I have closed an electric circuit, and I'm now finally be able to start to send those bumps, those ones, zeros, ones, couple of zeros, 1 0 1 0 1 0 0 0 zeros, 1 1 1. And don't ever think that this is so complicated. We will have videos for that. Chapter 1 is not simple. And let's say that I might receive the reply on the other end as well, and this will only be done when the circuit, electricity circuit, is closed. This is part number 1 for having a pair, that it must be a pair. But part number 2 is actually what's happening is, when I connect an electricity circuit or electric circuit, is that I will have to create, or actually by force or by physics of this nature of planet Earth, two domains will be created immediately when I close and operate that circuit: an electric domain or electric field, and a magnetic field that is actually operating 90-degree on that, perpendicular to the wave of the electric field, like it's in that way. You might think that's not that much different actually, but if you wanted to see that from the perspective of that eye, let me assume that I have this eye, and the eye is seeing from that side, looking from the side, then I will see the green color, I will see the electric wave goes up and down all the way, and at the same time there is the magnetic field going left and right, perpendicular to it, 90-degree between them. So again, what I'm doing is that I'm sending the electric field, at the same time I'm sending the magnetic field. So like I don't know how to do that, like emulated in my hands, because I will look stupid. Okay, but I'm sending two fields at the same time. Each one of the magnetic field will not interrupt, but will what do we call it, will implement some noise. Yeah, it will interrupt. Yes, it will interrupt and apply some noise to the electric field in that case, because it's touching it in every time, and that will definitely affect the transmission that you want to do. The solution will be to twist the pair of the copper wires. In that case, or doing that, using that solution, we will eliminate, seriously, not reduce, but eliminate the noise field of the magnetic field. We'll do that. So we will kill the magnetic field noise, because it will be twisted. It will no longer have the 90-degree perpendicular on that, so that it will not affect it anymore, and you'll have your pure electric field working. That's why they are twisted pairs. So they look like twisted pairs. You need a pairs, and these two pairs, like using, they were developed in categories. There was like category 1, also known as Cat1 at the beginning, and they kept developing until they reached the category 5, Cat 5. Here, Cat 5 carried 100 megabit per second, and then there is Cat 6 and 7 that they can reach up to 1000 megabit per second, and there are some types of Cat 7 that are enforced but exceptional, very exceptional, to carry 10,000 megabits per second. But the two pairs can carry, like if you use these two, they can carry 100 megabit per second, and the four pairs can carry 1000 megabits per second. By the way, there is something that I will have a video for it. Yeah, I will not mention PoE here. There will be a video for that. I remember power of over Ethernet, and we will talk there. But the idea is that this is the first type, the most famous type, still the most famous type until nowadays, until 2021. It's still being used in most of the offices, homes, small environments, etc. But of course, it will not run for longer than 300 like meter or such, or even, no, actually, no, not even for more than 100 meter. You will need a very good high quality Cat 7 or Cat 6e types to cross the 100 meter, but classically it's for distances less than 100 meter. So that's what you will need it. When it comes to the twisted pair, there is something called the unshielded twisted pair. You can see that each pair are unshielded, only the end is coated, and there is the shielded twisted pair, so that every twisted pair is already shielded. This cause the bits to be able to transmit further distances, longer distances, because it's already like coated with that material. Interesting. I forgot the name in English. I know it in Arabic. I'm sorry, from chemics lessons, but it will be coated so that it's like the aluminum foil, so that it will avoid any, like if that was the wire, we will coat it so that no noise ever will happen, no loss will happen in the signal of the transmission, and it will travel for longer distances. So you can use the STP or the UTP as well. The connector at the end of every copper cable is one single type of connectors called the RJ45, and you can easily know and see that on your laptop, on the back of your desktop computer, on so many devices it's available, and this is how you connect your cables through it. Okay, so the second type is called the fiber optics, or the optical fibers, because they are fibers that are carrying the optical technologies, light technologies. They are new, they are in high speeds. They were developed to start from 1 gigabit per second only up to 1 terabit. Nokia have reached one port fiber optic port that has the speed of 1 terabit at a time. So from 1 giga up to 1000 giga. In between them, there is 1.25, there is 10, there is 25, there is 40, there is 20, yeah, there is 100, there is 400, and there is the 1000. So all of these fiber optic cables are supported, fiber optic connectors are supported, fiber optics small form factor pluggable is supported as well. So it's all about speed and high quality. So one single fiber is enough here. Yes, we don't need to establish the electric circuit. So when I look at these two pairs, one of them is to send the data, the other is to receive the data. If one of them was corrupted, then I can continue sending without receiving. It can be applicable in that way. So we don't need to close the circuit in order to work. We don't need to twist in order to eliminate some field, etc. No, it's much more simpler, and I will talk about the types in a minute. So that will be their type. It started with 1 gig up to 1000 gig. It's either light or laser. Well, if you look with me right now to these cables here, leave the connectors, leave this, look at the cable itself, it's orange, referring to something called the multi-mode cable, the This is used for short distances because it sends light in a multi-mode. Like you will start sending light, let's say that this will be your cable, and from that end you will send the light will be sent like on a matter of waves, so it will keep touching the walls, or the the walls of that cable, the coating, this plastic coating. It will keep touching them, like hitting them on and every time, so multi-mode until it reaches the other end. Of course, this is only supported for distances of 300 up to 400 meters as maximum. This is the first type of the cables of the fiber optic, the multi-mode, that uses only light. The second type has a yellow color here, not an orange color. It's called the single mode. It's uses laser. So since it uses laser, then what it will do will be rubber, and I will have to delete that. It will do something simple, and that simple thing will be, I need the red is my color, is that it will send one straight, highly focused, high quality laser from the beginning to the end. Of course, no hitting on the ground, on the walls, no losing the distance, etc. will definitely make it being able to travel for longer distances. But how longer? Starting from 700 meter up to 80 or more than 80 kilometer, depends on the technology, but I believe 80 kilometers is supported, so it's in that way. Yes, I'm not exaggerating, 80 kilometers are supported as well, so laser is used there. How do the devices understand the light signals? Well, actually, if it was multi-mode or even single mode, you are sending light, so you are sending that in like let's say light, no light, light, no light, light, continues in that way, or a high frequency of light, low frequency for zeros, higher frequency for ones, but actually it's sent for light, light, no light. This is ones and zeros. For electricity, like electric, no electric, electric, no electric. This is how the other device records the 1100, 100, 111110 in that way, and it will collect your frame and then the packet, etc. How do the light become limited to certain speed? Yes. Now there is the smart question before I leave this slide. Well, you might think of, well, just in the slide before, you said 2 pairs can carry 100 megabit per second for copper cables. 4 pairs will be able to carry 1000 megabit per second. Here we are talking about light. You know how light travels fast? You know how light can carry, light is carried, like light has some 8 shades inside it, from red to purple, etc. So light, like, it can carry how much? Well, actually, when you look to a device that supports fiber optic, you will look at device that looks like that, 4 empty ports that you need to plug something in. So let's come for the connector, and the connector in that case is a part that from this end will be connected to the device, a router or a switch, and from that end it will have 2 holes expecting you to connect the connector to it. So you have something called the small form factor pluggable, the SFP component. This one is the connector, actually, that is connected to another connector here, which is the end of the fiber optic cable. Now this one will receive the light and will translate the light signals to electric signals and push it to your router. So in the end, back to electricity. Yes, because electricity that is running inside your router or switch, not light only through the cable. So when it comes to connecting two devices via fiber optics, you will need two components. Number one, the cable itself will come built in with a connector that you cannot cut. You will always need that built-in connector. Number two, you will need to connect the connector to the two holes available in the SFP and connect the SFP to your device. Regarding the connector on the end of each fiber optic cable, there are so many different types of famous connectors like LC, this one, SC for the big one, FC and ST are different but almost obsolete. MPO, MTP over MPO is for data centers and for different light technologies that you will study in service providers courses only. Okay, so 15 minutes are more than enough for this video, because in the upcoming video we'll talk about things a little bit different, absorb the amount of info here, and we can talk furthermore later. Thanks a lot.